Hi, welcome to my channel. Today, I am back with an exciting lecture on series circuit in which we will explore how we can connect resistors in series and will observe and practice their properties. We will solve numerical problems and will do simulation to validate our calculations. Let's get started. When we connect the resistors in such a way that second end of first resistor is connected with the first end of second resistor, they form a series circuit. Let's discuss the properties of series circuit of resistors. The first property of series circuit is that the total resistance RT is equal to the sum of all resistances. There is a special case in which we have all resistances of the same value. In this scenario, RT will be equal to N into R, where N is the total number of resistors and R is the value of single resistor. The second property of series circuit is voltage division. It means that total voltage VT will be equal to V1 plus V2 plus V3, and so on. The third property of series circuit is that current remains same through all element. Obviously, because it does not have any other path to flow. The fourth property of series circuit is that total power will be divided in each element according to its resistance. So PT will be equal to P1 plus P2 plus P3 and so on. Let's suppose we have a series circuit of resistors which consist of 4 resistors, R1, R2, R3, R4, where R1 is equal to 100 ohms, R2 is equal to 200 ohms, R3 is equal to 50 ohms, and R4 is equal to 150 ohms. We are interested to find the value of total resistance RT. As we know that total resistance is the sum of all resistance. So RT will be equal to R1 plus R2 plus R3 plus R4. Plugging all the values into the formula, we will get RT equal to 500 ohms. Let's simulate this in Tinkercad software to validate our calculations. I have built a series circuit with the same values as I have used in calculations. I have placed an ohm meter to measure total resistance of circuit. When I simulated the circuit, you can see that it shows 500 ohms of total resistance, which exactly matches with our calculations. Let's take special case scenario. Suppose we have 100 resistors of 10 ohms in series. We want to quickly calculate the RT. So, we will use the formula of RT equals N into R, where N is equal to 100 as we have 100 resistors in series. We have to just multiply N with value of any resistor, that is 10 ohms. So, RT will be equal to 1000 ohms or 1 kilo ohms. Let's place a battery of 10 volts for previous circuit, and now we want to find voltage drops across each resistor and also the current flowing through each resistor. Further, we also want to calculate total power being supplied by the source and power consumption of each resistor. Taking step 1, first we need RT, which we already have calculated and it was 500 ohms. Step 2. Solving for currents. As we know that current remains same through all series elements, so if we find the current of any element, it will be same for all other elements. As we have RT and VT values, so it is easier to find total current IT. Using Ohm's law, IT will be equal to VT over RT. Putting all the values, we will get IT equals to 0.02 ampere or 20 milliamperes. So I1, I2, I3, and I4 will be equal to 20 milliampere. Step 3. Let's find the voltage drops V1, V2, V3, and V4. Using Ohm's law, V1 equals I1 into R1. Putting values, we will get V1 equals 2 volts. Similarly, V2 equals I2 into R2. After putting values, we get V2 equals 4 volts. In the same manner, we can find V3 and V4, which will be 1 volt and 3 volts respectively. Step 4. Let's find the power consumption of each resistor. Power consumed by resistor R1 can be calculated using formula P1 equals I1 square into R1. Putting all values, we get pi equal to 40 milliwatts. Similarly, power consumed by resistor R2 will be P2 equals I2 square into R2. After plugging values, we get P2 equals 80 milliwatts. In the same manner, we can find P3 and P4, which will be equal to 20 milliwatts and 60 milliwatts. The total power calculated using formula PT equals VT into IT. By putting values, PT becomes 200 milliwatts. Now, according to law of conservation of energy, power supplied must be equal to power being absorbed by the circuit elements. Putting all the values of power, we can see that the equation satisfies the law of conservation of energy. Let's simulate the circuit to measure the current to validate our calculations. I have placed a power supply to power the circuit and placed 4 ampere meter in series of each component. Always remember that ampere meter should be connected in series to measure the current. We have calculated that current through each element was 20 milliampere. Let's start simulation and you can see that each ampere meter exactly shows 20 milliampere, which validate or prove our calculations. Now let's validate our voltage drops calculations. For this, I have placed voltmeter across each resistance. Remember that a voltmeter should be connected in parallel to measure voltage across any source or components. Now let's start the simulation and you can see that each voltmeter shows exactly same voltage which we have calculated.